Hello and welcome to my lab. Today I have for you two lasers in one package. This is a Quantronix laser. It's the Excel Dual Pulse 2000 and it has both a Neodymium and Holmium laser in one package. And with the switch you can switch which one of the two lasers you want, and each one of them has its own fiber output. Now as you can see, only one of the outputs is intact. One of them has this sort of handpiece and the other one is just a bare fiber. Now that's not the only problem with the laser, because if we try to use one or the other we run into a problem, so I'll demonstrate. Let's turn it on. So now it's starting up, water cooling starts to run. So we now have the Neodymium laser selected. So we go for Neodymium. We're at 10 Hz and half a watt. Well, let's up this a bit. So we can go to 8 watts. At 10 Hz, that means that the pulses will be 800 millijoule. So then we press this at try. You can hear already the flash lamp inside. So the laser is running, but there's nothing coming out of the fiber yet until I press the foot switch. Now I have a piece of black paper just to test out what it's doing. So let's have a go. So that one clearly works. Now let's switch over to the Holmium laser. And I have to select the Holmium. Let's also go for 10 Hz for the maximum power. This one only goes up to 4 watts. And now I have this bare fiber end. Now if we enable the laser, you can hear the flash lamps firing again. But when I press the foot switch, you can hear that the flash lamp stops and we get an error message. Now I don't know what the error means, I couldn't find a manual, but at the very least there's no light coming out and the laser has stopped. And it doesn't respond to any buttons anymore. So something is wrong with the Holmium laser. So let's have a look inside and see what we can find, and see if we can find out why the Neodymium side works, but the Holmium side doesn't. So I've opened up the laser cover, and inside the laser you can see that here on the top this is the actual laser head where the output comes out. The fibers plug into these boxes. And underneath here in the chassis is only the high voltage power supply and the water cooling and other electronics. So really the optical bits happen in here, and you can also see that because the water cooling actually goes in here, so the laser cavities will be in here. So I've removed all the bolts, so let's have a look inside. So here we see the two separate laser cavities. Each one has its own flash lamp, and parallel to this will be the laser crystal. This is actually a fairly compact unit, but for output powers of only a few hundred millijoules it doesn't have to be very big. So each one of them has the water cooling coming in and out, and the units look identical, but of course the flash lamp and the water cooling can be identical. The cavity mirrors and the laser crystal will be different, because that determines what wavelength it operates at. And in here is a shutter, and it works for both at the same time. Now you can see here in the corner a small clicky switch, because if you run this laser with this cover removed, it won't run actually. The cover is interlocked such that you can't run it with the cover removed, because now you can directly touch the high voltage terminals, and that would be dangerous. So that's why, for safety reasons, there's an interlock inside. So we may have to get creative if we want to see what's going on inside and run the laser at the same time. Now here is the high reflecting mirror, and the output coupler will be on this side. So let's remove this cover. Here it gets a bit more interesting. Here are two optics mounted, so I guess these will be the output couplers and these will be the high reflecting mirrors. So this will be altogether the laser cavity. Here are shutters mounted. You can see they are spring loaded with an actuator, and if I push them in, you can see that they can open up. Actually, they don't run that smooth, so who knows, that might be something that's actually related to the error message. Let's have a look at the optics in this second compartment. So here are the two output couplers. Those form the laser cavity in the first compartment, and the beams come out here. And you see that the whole layout is symmetrical. So if we follow this side of the beam, first we go to this folding mirror, and there's a small hole in the shutter assembly such that the beam can pass through. Then the beam reflects here, either to a folding mirror on the shutter that directs it into a beam dump, or it goes straight through to this folding mirror, which then reflects it here to a collimator that focuses it into the fiber that's on the edge of this compartment. So either the beam gets directed to the fiber, or it gets directed into the beam dump. Now there's more going on. You can see that after this folding mirror is another folding mirror, so this one leaks a bit of light, and that gets directed to this thing in the middle, and on the other side, the second beam path, you see the same thing happening. It gets directed to the same device. So I expect this will be some sort of energy meter to monitor the pulse energy. That's typical with medical lasers, because you want to be sure that whatever you've entered for the laser to output, you're actually getting it, because that depends on how well your treatment will go. Now I don't see any other optics inside the cavity, only just the output coupler and high reflecting for both the neodymium and the holmium side, so this is not a Q-switched laser. Which means that the pulse length will be determined by the length of the flash coming out of the flash lamp. And typically that's between, let's say, 100 microseconds and several milliseconds. So I don't actually know what the specification of the laser is. There's also no label anywhere on the laser that could tell me what the pulse length actually is. So let's see what happens if we defeat these two switches, bypass the interlock, and see what kind of output we get. I have a big block of aluminum, and if I place this off to the side, it weighs enough to press both interlock switches at the same time. So let's turn on the laser and see what's happening inside. You can see that now that I enabled the Holmium laser, that there's a bit of light coming from the flash lamp. That's the simmering. So a small current is run through the flash lamp, such that when the big discharge happens, it doesn't have to find its way through the flash lamp, but there's already a small conductive path that will be through the center by this very small discharge. So now I enable the laser and it should already start firing into the beam dump. Yeah, the laser is firing, the flash lamp is firing, the intermediate shutter has opened, but in the second box the shutter is still closed. So let's press the foot switch and see what happens. Well, to my surprise, it doesn't throw an error. Interestingly, now it works. So I'm not sure what triggers the error when I have the covers off in the normal situation. Of course, it's interesting to see that the laser works when you pull the covers off, but this is not what I expected. Now, I have the suspicion that I already fixed it. When I demonstrated these two shutters, I noticed that this one was feeling fairly smooth, whereas this one, oh, it doesn't feel as smooth as the other one. So I was wondering, what if the shutter was stuck? It has a feedback mechanism, and you can see here that it has a dedicated switch to check if the shutter is open or closed. And what if the shutter was stuck closed? Now that would generate an error message right as it wants to open up the shutter. So by massaging the shutter a bit, I may have already fixed this. So let's go in the reverse order of assembling the laser again, and let's see if it then still works. Now with the original covers on, I'll close the lid, but I won't screw it down because it's a lot of screws. I first want to check if the laser actually still works. So we start it up again. The Holmium laser is selected. We enable it. Half a watt, 5 Hz, good enough. Now you can hear the flash lamp pulsing, so now I should be good to go. Oh, that's again a different error message. I'm now even getting the 500 message at startup, so something is really wrong. Let's open up and see what's going on inside. I think I've spotted the problem. You can see that the shutter here is slightly upwards, and it's probably still depressing this mini switch. So if I press it down, now it's fully all the way down. Now to clear the error, I have to restart the laser. Hey, the error message changed to 400 and to 504. So something has already changed. Now this actually strengthens my suspicion of the shutter, because it was sticking slightly up when I got the startup error. Error number 4. I've only seen that once when the fiber wasn't connected. I left the shielding open. Of course, error number 4 is also the interlock. So I should place this back again. You see, the beeping stopped. That was the error. Okay, so error 500 has cleared. So I'm pretty sure that error 500 is also related to the shutter. I guess error 600 is the shutter not opening, and error 500 is the shutter not closing. So let's bring out a piece of paper again and see if I shoot on it, if I get some output. So I select the Holmium. I want to go a bit up in power, such that I can see bigger sparks. So let's enable the laser. And let's fire. Now you can see it actually works. So the laser itself works fine. The problem is, if I don't point it at the paper, you can see a small glow at the end of the fiber. The fiber is actually damaged, and I'm burning parts of the fiber now that I'm not pointing at anything. and you can see it very clearly, that this small lighting up of the fiber is the damage of it. Now I've let go of the foot switch and immediately it throws error 500. So let's put the fiber away, open up the laser again, and indeed the shutter hasn't returned. You can see that the shutters really aren't precision mechanics, there's quite some play in them. And the friction of them will be just a bit too much for the actuators to overcome, and then it gets stuck. And with the sensing that it does in the shutter position, it will throw an error message. So I'll simply lubricate all points that move with a bit of oil. Now you need to be careful to apply oil in between all the optics, because you definitely don't want to get oil on the optics. But in this case I've only applied it to the mechanical parts, and I just need to remember that touching those means you get dirty hands and you shouldn't handle any optics. To fix the fiber I had to remove the yellow coating. It turns out that the easiest method to remove it was to burn it away. After that I could cleave the fiber. The fiber cleaver was not made for such large diameter fibers, but the result was usable. With the shutter fixed and the fiber fixed, this laser is now ready to go. So it was a short and fun project. I hope you enjoyed watching it, and I hope to catch you next time.